JetXpert is proud to present the JetXpert, the premier drop watching system for inkjet printing. Drop watching systems are especially useful for inkjet developers. Before drop watchers, developers could only produce an ink and evaluate its effectiveness by inspecting the printed image. The JetXpert drop watching system fills in the gaps by viewing ink leaving the nozzle, drops in flight, and drop substrate interaction. In this video, we will explore the JetXpert system and learn what it can do. Then, we will learn how to expand the JetXpert capabilities through the available add-ons. Finally, we will learn what it takes to operate the system and record our first measurements. Now let's explore the parts of the JetXpert system and learn more about how it works. There are three main components to the JetXpert system. The print head is attached to the center of the system, using a mount customized to a specific head. JetXpert is extremely versatile, performing measurements on drops anywhere from 1 picoliter to 1 milliliter in volume, and handling input frequencies up to 120 kHz. Because of this, JetXpert is able to work with all print head and ink combinations, including Dymatics, Epson, and Kyocera. On one side of the print head is a high-speed LED strobe light with a minimum pulse width of 125 nanoseconds. On the other side of the print head is a zooming camera system with a field of view from 1 to 6 millimeters. All three of these components are synchronized so that the print head fires, the light flashes, and an image of the drop is captured. As the print head is firing, we are able to watch a live video of the process. This is a good first step in determining the quality of the ink and printing process. We want to see consistency between the drops, both from nozzle to nozzle, as well as the same nozzle over time. In addition, we want to see the ligament present during drop formation collapsing into the drop, without the formation of satellites or smaller drops. Images can easily be saved for later reference, and we can even record a video for sharing with others. The most powerful aspect of the JetXpert is the measurement capability. For a single drop, the system can measure volume, velocity, trajectory, and time of flight, all automatically as the ink is being printed. This data is easily viewed within a measurement report that is updated in real time. Let's explore the measurement report further. Here are our 4 measurements being performed on each drop: average radius, volume, trajectory, and velocity. Next to them are the values for the most recent drop. For example, this drop had a volume of 30.045 picoliters and was traveling at a velocity of 3.243 meters per second. The lower box is for statistics that are updated for all of the measured drops. These statistics show the mean, standard deviation, minimum, and maximum values for each of our measurements. For example, the average volume of all the drops we have measured in this experiment is 30.305 picoliters. The individual measurements from each run are automatically saved in a user-defined file, readable by Microsoft Excel. Within Microsoft Excel, it is easy to integrate this data into tables, charts, and graphs for easy analysis. JetXpert also has a suite of available add-ons that give it increased functionality and measurement power. A second camera and light source captures images of the nozzle plate. This is known as wetting and is useful for viewing ink pooling on the nozzle plate, debris or damage to the nozzles, and missing jets. Frequency sweep allows the user to measure and visualize how jetting frequency affects drop behavior over a range of user-specified frequencies. JetXpert automatically changes the jetting frequency of the head controller to each frequency in the list, makes measurements, and records data and images. With frequency sweep, we can automatically plot the relationship between frequency and drop formation, volume, velocity, and trajectory. Sometimes, after periods of non-printing, the first drop or several drops ejected from a nozzle will behave differently from the other drops. For many applications, it's critical to know the amount of time the ink may remain idle between periods of printing before drop performance is impacted, and how long it takes the head to recover afterwards. The available latency add-ons include two different analysis tools, which together provide the solution. The first kind of analysis, which is called latency sweep, images and measures the first drop out of the nozzle after each period of rest in a user-defined list. For example, 1 second, 2 seconds, 3 seconds, and so on. In this way, the user can easily determine the maximum rest time before drop performance is impacted. The second kind of analysis, which is called latency multi-drop, images and measures the first drop out of the nozzle after a user-defined period of rest, as well as the second drop, third drop, and so on. With this tool, a developer can clearly see how long it takes the head to recover after a given period of rest. The standard JetXpert system includes 3-axis manual control. JetXpert Motion automates the movement of the head between nozzles. JetXpert Motion allows the software to move the head, scanning the entire nozzle plate from edge to edge. Developers can automatically measure each nozzle or any specified range of nozzles. Ensuring all nozzles are firing consistently and reliably is an essential part of sustainability testing. JetXpert Stitch quickly and automatically captures complete information about drop formation in a single image. For many applications, it is easier to display and share an image than a video. This feature is especially convenient for producing marketing materials, sending in an email, or for presentation and reports. Good jetting performance is necessary for good print performance, but it's not all that's needed. Matching an ink formulation to an appropriate substrate, and in some cases substrate coating, is equally important. With the JetXpert Print Station, users can quickly and easily switch between drop watching and printing on their own substrate. The drop watching portion of the Print Station utilizes a standard JetXpert system and printhead, along with a printhead driver and ink supply system. The printing portion of the Print Station includes a belt with an encoder, adjustable speed control, and sensors for product detection. While using the JetXpert system, we see that the screen contains two important windows. On the left side of the screen is the image buffer. This is where images taken using the JetXpert camera will appear. On the right side of the screen is the user interface. The first thing we want to do is start jetting using the print controller. Now that we are jetting, we are ready to start the strobe and visualize the drops. The mode we are looking at now is called variable delay. This allows the user to visualize the drop evolving over time. In this case, we will begin looking at the drop 30 microseconds after it has been fired and continue until 180 microseconds after firing. By adjusting the step size to 10, we have elected to view the drop in increments of 10 microseconds within that time frame. In this mode, we want to see that the ligament is collapsing into the drop without forming satellites, which is the ideal behavior for an ink. If at any time we want to switch over to the wetting camera view, we can simply press the wetting button here. This will view the same nozzle from the underside of the nozzle plate. This is useful for checking the status of the nozzles. Because we do not see any black pools forming or any irregular behavior, this ensures that the nozzles are firing correctly and we can continue with our analysis. The second mode we will look at is called single pulse. This is for viewing the drop at a single moment in time. In this case, we are viewing the drop 190 microseconds after it is fired. If we want to look at the drop in a different point in time, we simply change the value of delay 1. For example, let's look at the drop 100 microseconds after it is fired by entering 100 here. We are looking for good drop-to-drop consistency in analyzing the performance of our ink. If the image appears to be standing still, this means that the drops are perfectly consistent and the ink exhibiting ideal behavior. The third mode is called double pulse. Unlike single pulse and variable delay modes, which are used for drop visualization, double pulse is for measurement. With double pulse, the strobe light flashes twice for each image, so we see the same drop in two different places. If the drops are within the box, or region of interest, then we are ready to make measurements. To begin, press the button labeled Analyze Now. A measurement report appears. This report shows the radius, volume, trajectory, and velocity of the drop. The bottom half of the measurement report shows statistics as multiple drops are analyzed. The statistics show the mean, standard deviation, minimum, and maximum of each of the drop measurements. If we want to make these measurements on many drops automatically, we simply hit Analyze Multiple. Now the software continues to run and collect that same data on many drops as they are printed. Note that the statistics are continuously updated. Each individual analysis result is automatically saved in an Excel readable file, located in the Data and Reports directory. The file name is determined by the user in the Data File Name field. The user can also enter comments or an experiment ID, which are included with the data. As you can see, each line in the Excel sheet shows the result of an individual analysis, including radius, volume, trajectory, and velocity, and if desired, a timestamp. From here, the data can be manipulated however we would like into charts, tables, or graphs. If we want to collect a video of what we see here, we can simply hit Start Recording. Once we have the information we want, we hit Stop Recording. The software automatically saves the video, as well as each individual frame. These files are stored in the Saved Images directory. Video files appear as a folder with a timestamp. Within the folder, each individual frame of the movie is saved in TIFF format, along with an AVI file, which is the movie itself. Videos can also be recorded using the wetting camera, in which case they have a W suffix. Here's what the AVI file looks like. We can easily drag this video into a PowerPoint presentation if we choose. The JetXpert workstation comes preloaded with Microsoft Office. Congratulations! You are now ready to begin your own analysis using the JetXpert system. For brochures with more information about our products, visit us at JetXpert.com. For more videos of JetXpert being used with various print heads, visit Image Expert's page on YouTube. You can also email info@imageexpert.com for 3D drawings of parts, to ask specific questions, or to request a quote. Thank you from all of us at Image Expert Incorporated.